Okay, here is an interesting question. We are given this recurrence relation where T1 equals to 1 and Tn plus 1 is Tn plus floor of, this is floor, right? Floor of square root of n plus 1 for all n greater than equal to 1, right? So this is the recurrence relation given. Now the question here is, what is the value of T of m square, right? For m greater than equal to 1. And you're given these four values. And remember, this is not big O or theta or omega notation. This is the exact value that they're looking for. So let's start with this. So we'll come to Tm square. If you look at this, let's look at the graphic behind it, right? So if I have a problem, so I want to understand what is Tn plus 1. Tn plus 1 is Tn. Look at this. Tn plus 1 is Tn plus floor of square root of n plus 1, right? So if you draw this is the graphical way to understand it, right? This is the tree based approach, the recurrence tree based approach. So I can write, so a problem of size n plus 1 is broken into a problem of size n, and there is a floor of square root of n plus 1 time, right? Problem of n is broken down to problem of size n minus 1, and there is this time. So on and so forth, you'll reach up to 1. And you're given that T of 1 equals to 1. Now, the total time to solve this problem of size n plus 1 would be this plus this plus this plus this, everything and plus 1, right? So if you notice, T of n plus 1 is floor of square root of n plus 1 plus floor of square root of n, this term, this term, this term, up to floor of square root of 2 plus 1. Right? So I've basically taken this recurrence relation and simplified this recurrence relation to obtain this. Very straightforward, nothing very fancy till now. Now, instead of n plus 1, if I replace n plus 1 with m square, because the question is, what is the value of Tm square? That's the question. If I just replace it with m square, what do I get? Here we have n plus 1, here also we have n plus 1, n up to 1. So T of m square would be basically floor of square root of m square, and this is nothing but m. If you think about it, this is nothing but m plus floor of square root of m square minus 1, so on, floor of square root of 2 plus 1, right? Here we are given four options. The fastest and the easiest way to solve this is by elimination. Okay, let's just do this. Okay, T of 1 is equal to 1. We're already given that. We're already given that T of 1 equals to 1. Now, right, if m equals to 1, m square will be equal to 1. Right, which means if I replace m with 1, let's look at what all values will I get for options A, B, C, D. A will return 1, B will return 1, C will return 5, D will return 5 by 3. What did I do? I just replaced m equals to 1 in these formulae. Right, in each of these expressions that I'm given, I just placed m equals to 1 and I computed the value. It took me a little while to compute it, but if you compute it, you get these four options. And we know that T of 1 equals to 1. Which means C and D cannot be the right answers. They have to be either A or B, because only, see, this is by elimination, right? So I've eliminated option C and option D using T1 itself. Now the question is, amongst A and B options, which is the correct one? Then what did I do? I took m equals to 2, which means m square will be equal to 4, right? And I computed Tm square. What will Tm square be? Tm square will be square root of 4 plus floor of square root of 3 plus floor of square root of 2 plus 1. Right? This is your Tm square. Right? Now I computed this. I also computed the four options with m equals to 2. Right? That's what we have done with m equals to 1 in case 1. Case 2, this is case 1. In case 2, I tried with m equals to 2. Even in this case, because I have to now choose between A and B. Both A and B were becoming the valid options. So I can't still determine if A is the right answer or B is the right answer. I still can't do it, even with m equals to 2. So I tried with m equals to 3 also, it didn't work. Then finally I went to m equals to 4. When m equals to 4, m square equals to 16. So Tm square will be exactly this. I just expanded this. Now if you notice, what is this? This is 4. What is this? If you notice, square root of 15 is some 3 point something. Because square root of 16, remember, square root of 16 is 4 and square root of 9 is 3. So square root of all the numbers between 15 and 10 will be 3 point something, right? And if you take the floor of each of them, the floor of all these 6 numbers, the floor of square root of 15 up to square root of 10, all of them will be 3, right? Because they are 3 point something, 3 point something. If you take floor, everything will go to the integer less than this. So how many numbers do I have? I have 15 to 10. I have 6 numbers here. I have 6 numbers here. And for each of them, the floor value of square root will be 3. So I did 3 into 6. Now, next comes my next term. Floor of square root of 9. Square root of 9 is 3. So I just placed 3 here. Next, if you look at the rest of the numbers, between 8 and 5, the square roots will be 2 point something. Because square root of 4 is 2. Square root of this is 3. Right? Square root of 4 is 2. Right? For how many numbers are here? I have 4 numbers, 8, 7, 6, 5. For all these 4 numbers, if you take the square root and floor, you will get 2 into 4. So this corresponds to 2 into 4. This corresponds to 3 into 6. Now I have square root of 3, floor of it, which is 1. Square root of 2, again 1. So 1 into 2 and 1 itself. So T of 16 is 38. Now T of 16, which means for m equals to 4 here. So I simply placed m equals to 4 and computed the value of option A and option B. What it should be 38, right? So when I applied m equals to 4 to option A, I got a value of 34. When I applied m equals to 4 to option B, I got 38. So we decided that C and D cannot be the right answer, right? We already eliminated these two. We are left with only options A and B. So now B is the right answer, right? Of course, there are many other ways of solving this problem, but this is one of the fastest and also slightly tricky because you have to try many options like this. First of all, you solved a recurrence relation. Then you tried case with m equals to 1, m equals to 2, m equals to 3 also didn't work. Finally, case 4 with m equals to 4 ended up helping us determine whether option A or option B is the right answer. So little time taking if you have to really solve it, but it's worth this try and it's much faster this way.